look at this one, the region in the first quadrant bounded by the graphs of y equals 1/8 x squared, 1/8 x cubed, and y equals 2x, is revolved about the y-axis. So we've got this region right here. Since we're going around the y-axis, whoops, that's not the y-axis. Since we're going around the y-axis, we're going to use a dy cut. So again, with discs and washers rotating around the y-axis, it has to be a dy cut. Rotating around the x-axis has to be a dx cut. So if we take a look at that rectangle, like we did in the last problem, get this horizontal rectangle, draw one just like it on the other side, and we connect the inside parts with the oval, outside parts on the bottom. That was not my best, but you get the idea. We need to have a washer here with a hole in the middle. Right, so our little radius is always from the axis of revolution to the closest part of the rectangle, or to the closest function. So if we look up here, little radius goes from the y-axis to the line. Big radius is always going to go from the axis of revolution to the farthest part. So to the farthest function. So our little radius goes to the line, and this time we have a horizontal radius for the little radius, horizontal big radius. So that's really like an x value, right? Horizontal distances are in x. So our radius would be x, but we're doing a dy cut, so everything has to be in terms of y. Normally, you'd get maybe equations like this. You'd have to solve them for x in order to put them in a dy cut problem. Well, they've kind of been done for you already. Right here, it says x is equal to 1/2 y, right? Just dividing by 2. And it solved the other one too. Here, if we multiply both sides by 8 and take the cube root, we get x equals 2 times the cube root of y, or 2 times y to the 1/3, like they have it written here. But our little radius, again, goes from the x-axis, the y-axis, to the line. So our little radius is going to be 1/2 y, and it has to be in terms of y. And our big radius is going to be 2 times the cube root of y, or 2 times y to the 1/3. And that's the further function, the one that's furthest away from the axis of revolution. So we can set up our definite integral. We're going to have pi times the definite integral from smallest y value, which is what? 0. Biggest y value? 8 y value, not x value. Right? So again, they've kind of done some work for us here. If we didn't have this done for us, we could find this intersection point if we graphed them and calculated the intersection point, or we can set these equal to each other to solve and find out where that point is if it's not given to us. But then on the inside, we have the big radius, 2 times cube root of y squared, minus little radius squared, so 1/2 y squared, times the height, in this case is dy. Now, it may help you to write this the way that they had it. The cube root of y, as far as like put it in your calculator, you may want to just do y to the 1/3. Although there is a cube root button, you have to kind of search for it. Raising it to the 1/3 might be a little bit easier. But if you work that out, we should get, let's see, I think it was 512 over 15 pi. Yep, 512 over 15 pi.